All right, we're gonna talk about evaluating polynomial functions. We kind of talked about this earlier, um, but now we're gonna talk about it more formally. So when we're evaluating functions, we talked about, functions are like a machine. We have like, this is f of x, and then we have our input, which is x, and then we have our output, which is y, right? So that's what we're gonna do. Um, Here it says find each value. It says f of 3. So that means we're going to put 3 in for x and get out a value, which is y. So 4 times 3 cubed minus 3 squared plus 5. We do 3 cubed first because PEMDAS, so 4 times 27 minus 9 plus 5. You do 4 times 27 on your calculator. I get 108, so 108 minus 9 plus 5. So 99 plus 5 gives me 104. Okay, so a lot of times we would say f of 3 equals 104. So when I plug in 3, I get out 104 as my y value. Okay, all right, so f of negative 4. So 4 times negative 4 cubed minus negative 4 squared plus 5. So this is a good thing to talk about. When we raise a negative, I don't like how I wrote that. So when I take a negative to an odd power, remember it's going to come out negative. But when I take a negative and I raise it to an even power, it's going to come out positive. Okay? So negative 4 cubed is going to be 64 minus negative 4 squared is going to be positive 16. Okay? So that's something that you should remember. And I think we talked about that on another video too. All right, so 4 times 64 is 256 minus 16 plus 5. 256 minus 16 gives me 240 plus 5 gives me 245. Okay? All right. All right, so adding polynomial functions rule. So let's say I want to add two polynomial functions. This is how we express that, f plus g of x. Now, sometimes we also do f of x plus g of x, okay? Which is just saying we're going to add them, okay? So here we go. Anytime you see f plus g of x means I'm just going to add the two functions together. So I'm going to do x squared minus 3x plus 7 plus negative 3x squared minus 7x plus 7. So here we go. X squared minus 3x squared. Let me pause. This is like adding polynomials. And when did we do adding polynomials? It was on the last video. So 4.1, 4.2. Okay. So I remember we dropped the parentheses and then just kept the addition sign. And then we just combine like terms. Sorry, I needed to go back and make sure I use the same language. So x squared minus 3x squared is going to be negative 2x squared. Negative 3x minus 7x is negative 10x. And then 7 plus 7 is 14. Okay? Now, same thing happens if we're subtracting. So you'll see it as f minus g of x. That just means f of x minus g of x, which we also talked about in the 4.1, 4.2. Okay. Now, remember, when we're subtracting, something special happens. We have to drop the second set of parentheses, but distribute the negative because we're subtracting all of them on the back end. So we're going to drop the first set, but change the signs of all the seconds. So it's going to be plus 3x squared plus 7x minus 7. So you see how I kind of like distribute a negative one, change all the signs. I don't care how you look at it as long as you know that it changes, okay? Now let's combine like terms. So this becomes 4x squared plus 4x and then that's going to cancel. Okay? All right, so same idea as adding and subtracting polynomials. So nothing really changed except for the verbiage, right? Or how it's presented. Okay, we just presented it in a function notation. Okay, so let's do it again. So I want f plus g of x. So I'm going to take f of x, and I'm going to add it to g of x. Nothing crazy. If you want to do it in parentheses, just because that's how we did it, we drop the parentheses and nothing changes. And in this case, it's just going to be 10x squared. Okay. Oh, something did change, didn't it? There's a 2 there. So let's go up here. What did this mean? This means I was putting in a value. I was wondering why we're doing the same thing. Putting in a value. So not only do I find f plus g, so I found f plus g of x first, right? I promise I've had my coffee this morning. All right, now I'm going to plug in 2. Okay, so 10 times 2 squared. 2 squared first, and I get 40. Okay, so my final answer is 40. So a lot of times when we're doing these multi-step problems, you're like, Mrs. Weddington, where do I stop? Okay, so I'm going to start saying this is the answer. This is where we stop, because you're going to start giving me, you're going to start doing more, and I don't want you to do that. I want you to know where to stop. Okay, all right, here we go. F minus g of 1. Okay, so first step, f minus g. So 10x squared minus 2x minus 2x. Okay, now since there's only one thing on the back end, it doesn't do too much. Just change it to a negative, right? So I get 10x squared minus 4x. Perfect. So second step is to plug in 1. Okay, so 10 times 1 squared minus 4 times 1. 1 squared is 1. 10 times 1 is 10. 4 times 1 is 4. 10 minus 4 is 6. This is my answer. Okay? All right. So, we need to start talking about basic polynomial functions. I need to make sure this isn't 4.5. Okay, no, we're good. Okay, so we're going to talk about 3 basic functions today. F of x equals x, f of x equals x squared, f of x equals x cubed. These are very important functions. They're like the 3 base functions. And we're going to talk about the domain and range of the functions and what they look like. And you need to memorize kind of like the table, okay? Because we're going to learn how to graph them. All right, so here we go. So f of x equals x. So that's the same as y equals x. So let's do our table. So anytime we do our table, I'm going to tell you what numbers to pick. -2, -1, 0, 1, and 2. So those are the numbers we are picking. Okay, so if I put these x values into this function, I'm going to get out -2, -1, 0, 1, and 2. So we're going to graph these. -2, -2, -1, -1, 0, 0, 1, 1, and 2, 2. So here we go. Let's connect the dots. Now, let's talk about the domain and range. This doesn't have a fraction, and it doesn't have a root. No even root. So that means its domain is -infinity to infinity, and its range is also -infinity to infinity. We can put anything in, and we can get anything out. Okay, so we have the table that we're always going to use for this, like, parent function, I'm going to call it. Okay, and this is the graph of that function. domain and range of that function. All right, let's do the next one. So this is going to be y equals x squared, or f of x equals x squared. Okay, so our -2, -1, 0, 1, and 2. So if I put that in, I get 4, 1, 0, 1, 4. So I'm going to graph this. 4, 1, 0, 1, 4. So that's my graph. So my domain, again, no fraction, and then no even root. So domain's -infinity to infinity. Now my range. Remember, we look at where it tops out or bottoms out. So this one bottoms out. So it goes from 0 to infinity. That's important. So this is my parent function table. And this is my graph. Okay? All right, we got one more. We got y equals x cubed. So same points, -2, -1, 0, 1, and 2. So if I plug that in, I'm going to get -8, -1, 0, 1, and 8. Let's graph that. So -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. Let's graph it. Okay, so now this one's a little bit different. Again, still no fraction, no square root, -infinity to infinity. But its range, it doesn't top out or bottom out, so it's also -infinity to infinity for the range. Okay? All right, so now we're going to graph transformations of these polynomial functions. We're going to use the same table, and we're just going to plug in our numbers and get out new numbers. Okay? So, -2, -1, 0, 1, and 2. Now, we're going to graph our original function. So this original function would be y equals x. That's the parent function. So we knew our parent function was -2, -1, 0, 1, and 2. Because I want you to be able to compare it to what it used to look like. So there's our parent. Okay. So here we go. Y equals 2x. So let's plug in. If we plug in -2, we get -4, -2, 0, 2, and 4. So when we graph that, I'm going to graph it pink because it's just going to stretch. So -2, -4, -1, -2, 0, 0. Oh, I screwed up. Oh, it doesn't like me. Okay, so -2, -4. There we go. So you see how it tilted a little bit? 1, 2, and then 2, 4. So the slope just changes, right? So there we go. Now, the domain and range does not change. Okay? All right. Graphing takes patience. I am not a big fan of graphing, so it just takes a lot of patience on my part too. All right, so parent function is y equals x squared. -2, -1, 0, 1, and 2. Let's know what the original function looks like. 4, 1, 0, 1, 4. So 4, I messed up. 4, 1, 0, 1, 4. Okay, so if I do y equals -x squared, now this is a little, I'm going to show you. Remember we talked about if the negative's on the outside, we give to the negative afterwards. So I want to show you something. -2 squared. So that's going to be a -4. -1 squared. It's going to be a -1. 0 squared. Or -0 squared, which is 0. -1 squared. -1. -2 squared. -4. Okay, so the new function is going to be -4. So -2, -4. negative 1, negative 1, 0, 0, and 2, negative 4. There we go. Oh, it wanted to make a circle. Okay, there it is. All right. Now, my domain, still negative infinity to infinity. My range, this one tops out. Okay, so that means the top of it's going to be 0, but the bottom is going to be negative infinity. Okay. All right. Here we go. Let's do our original. My original is going to be y equals x cubed. So negative 2, negative 1, 0, 1, and 2. So I get negative 8, negative 1, 0, 1, and 8. So negative 8, negative 1, 0, 1, and 8. And it's squiggly, right? Okay. And then I've got y equals x cubed minus 2. So it might be good to do like I did on the last one when there's some computation to kind of do it like this. So we've got negative 2 cubed minus 2. So it's going to be negative 8 minus 2, negative 10. Negative 1 cubed minus 2. Negative 1 minus 2. It's going to be negative 3. 0 cubed minus 2. Negative 2. 1 cubed minus 2. That's going to be negative 1. 2 cubed minus 2 is 8, 7, 6. Okay? Just double check that. Negative 8 minus 2. Negative 1 minus 2. 0 minus 2. Okay. Every one should have moved down 2. So, all right, perfect. So here we go. So I've got negative 2, negative 10, negative 1, negative 3, 0, negative 2, 1, negative 1, and 2, 6. There you go. So domain's still negative infinity to infinity, and our range is also still negative infinity to infinity. This one doesn't change very much. Okay? All right, the last thing we're going to talk about in 4.4 is composition. So what composition is putting one function inside of another and then expressing that as a new function. So we actually get a new function. So oftentimes we see that as f and then a circle g. And we express that as f of g. F of g of x. Okay. You'll see it and they'll call it fog. I always rewrite it as f of g of x so that you can see that the g is inside. Okay? And then sometimes we see g of f of x. Okay, we say that's g of f of x. And then I rewrite it as g of f of x, or putting f inside of g. Okay, I'm going to teach this a new way, and I really like this because it kind of makes sense, okay? So this first one is f of g, right? Okay, so I'm going to rewrite it f of g of x. The g is inside of f, okay? So I need to put my g inside of my f function. Well, what I'm going to do is I'm going to take my f function and I'm going to leave blank spaces where the x's are. So you see that? Okay. Anywhere I have blank spaces, I'm going to put the g. There it is. Now that's x plus 3 squared, and we're going to leave it there because I haven't taught you how to FOIL yet. So we're done. All right, g of f. So remember, I want to rewrite that as g of f of x. So that's saying I want to put f inside of g. So I'm going to take my g, anywhere there's an x, I'm going to leave a blank, and then I'm going to put my f inside of that. Okay? So the answer is x squared plus 3. Okay? All right. So C, f of g of 4. There are two ways you can do this, and I'm going to show you both ways. You can get the composition first, then put in 4, or you can start from the inside out. So f of g of 4. We've actually already found f of g, which I'm going to redo it. So f of g of 4, okay? So f of g we found was x plus 3 squared. Now I plug in 4. 4 plus 3 squared gives me 7 squared gives me 49. Now the other way you can do it is we can start with the inside, g of 4, and find that, okay? So g of 4 is 4 plus 3, which is 7. So now, since we know g of 4 is 7, now we can find f of 7, which is 49. I don't care. Pick your poison, okay? Either way. So now g of f of 4. So either we can do g of f of x first, which we found to be x squared plus 3. Plug in 4. 16 plus 3 gives me 18. Or we can work it to be g of f of 4. Do f of 4 first, which gives me 4 squared, which is 16. Then do g of 16, which is 16 plus 3, which is 18. Oh, guys, it's 19. Wow, I'm glad I can do math. I was about to get all the emails on that one. Okay. Are we good? Cool. All right. So a little bit harder example. So we're going to do f of g of x with these. So f of g of x. So I'm going to put g inside of f. So that means I'm going to start with f and leave blanks where the x's are. And then I'm going to put g inside of it. And if there's more than one term, I put parentheses. Then I'm going to distribute. And then I get 4x squared plus 19. Okay? And then g of f of x. I'm putting f inside of g. So I'm going to start with g, leave blanks, put my f inside. I haven't taught you how to FOIL yet, so you can keep it like that. All right, that's it for 4.4.